I'm going to talk mostly about hope, what the XO represents, and hacking, because that's a lot of fun. And I'm going to start off and really just sort of chat about the hope of the XO. This is a piece of technology about children, and it's a piece of technology about education. Because the biggest thing that we can do in our lives is to figure out how to educate all the children. Now, right now, education is something that is a little hard to get a hold of. We keep thinking that we need large presentation systems and we need AV systems in schools. But our technology has progressed far enough that we can do it with a laptop. And these gains keep coming. On a personal side, when I was about 3 or 4, I lived in Kanpur, India. That my father was one of the first professors to go over and start up what at that time I think was the 4th IIT university. And they just moved over there, and he took a move that was not so conducive to good careers, but he felt it was important. And he ran over to India and started teaching classes, and they'd come in, and it was a madhouse. They'd say, you know, well, we have somebody who wants to meddle in metallurgy. They want to major in metallurgy. We need some classes, we need a course description for the classes, and we need to know what they need to have to graduate, because that's what they were doing. They came over and they started up, and now IIT has become a major university. And what happened is the people that went there were able to generate enough wealth that India became a much greater country than it had been at the time they went. Now, in this case, this is the XO. So it's going to be going in, and it's going to be taking what is an expensive piece of technology for the area and dropping it into different places, mostly fairly poor, India, Bangladesh, New Orleans. And the thing is, this is most of what you need now for a good education. This is a different type of computer. It's designed really for collaboration at its heart, as a window into the world that you can play with. And right now, you've got kids picking it up and going. We know that if you give kids laptops, they figure it out. And this is a very well-designed laptop. What you'll also see is that those children will go beyond what you expect them to do. And they will make new products, and they will go out, and they will make some money and bring it back. And at first, it doesn't look like much. I mean, right now, you're seeing deployments of, oh, we dropped 1,000 laptops here or 10,000 laptops there into some country. And it's not the millions that you thought. But never forget, exponential growth has a way of sneaking up on you. So that's about the dream that they're selling. And references for those who are watching carefully. And this is about the reality. So you want to go hack on this beautiful piece of machine. It's a beautiful machine. If you look at the hardware, it's probably some of the sweetest hardware that's come out in a while. Everything from, oh yes, if you disassemble it, they have spare screws in the handle in case you lose a few, to the fact that you don't get dust in it, or they took what was the radical approach and will probably be the standard approach in 4 months of just mounting the whole thing on the back of the display. So it's a beautiful piece of hardware, and you could have a whole hardware talk about it. And the hardware is actually very nicely stable, the full hardware. The firmware is pretty stable. The OS is a modified Fedora core, so it's basically a Red Hat Linux, and you have access to all of the shells and Linux commands if you want them. That's changing a little. For example, these do not take full advantage of the hardware. A lot of the power-saving systems have been turned off. This does not hibernate right now. It does not turn off the CPU when the CPU is not being used. There's a lot of power-saving tricks that are accessible at the hardware level, some of which is accessible at the firmware level. Less of it is accessible from the OS. And from on top of the OS, you're basically programming in a variety of languages, with things that GStreamer and PyGDK, all of the libraries you know and love. But it's a brand new machine. Most people who have it in this room have had it less than a month. A lot of the information for it is kind of squishy, and so you hang out on chat rooms and you try to find things out. That's moving from kind of bleeding edge dangerous technology to leading edge technology is where it is now. If you want to go through and actually start hacking on it, very first thing to do is just get comfortable with the thing. It's going to be a bit different than you expect. They run underneath a shell, the Sugar CRM shell. The Sugar shell, not to be confused with the Sugar CRM system. But it runs underneath the Sugar shell. You don't see a file system as a user. You don't, every now and then you'll be playing with it and say, oh, well, you don't see passwords, and then a day will go by. What I noticed yesterday is I never clicked through a license agreement. There are just no license agreements. There are no modal dialogues. There are no dialogues. So the interface is a little different. You're going to have to go get comfortable with it. My checklist for getting comfortable with the system, so I suggest you sit down and you play with it, and you run through the applications. You'll find that it has a nice programming environment for turtle art, basically a stripped-down logo for turtle graphics. Go write a spirograph in it. Go play with their eToy Squeak implementation that's also a drag and drop pieces around or change a few items around. Run through its tutorials. Then you're going to find that just like the whole machine setup for collaboration, a lot of the things you want to get comfortable with require you to find a couple more people with them. You want to set up a mesh and you want to do these interactive two-person editing of documents, or you want to do the things that we physically require two laptops. Like there's a acoustical, we send a noise, we listen to it on the other end, we tell you how far away you must be. These things take a little while. You're going to find a lot of things where you get stuck. If you get stuck, ask a 7-year-old. We are young and curious at heart. They're young and curious and don't expect things to be wrong. We'll go hunting around for the power cord, they'll pick it up, and it'll be the first place they push. So go through, there's some reading you should do. You should read the basic little getting started manuals, learn the cheat keys because you'll need them, and go ahead and flash the firmware. The firmware you can download and upgrade. There's always something that changed. Upgrade the operating system once. Once you start getting comfortable with the system, then you should probably start going in and writing your code. Oh, and getting a developer's key, you don't need it to actually program. Getting a developer's key involves going to a web page from the XO and say, give me a developer's key. And it says, great, come back tomorrow and you'll have it. It's not a big deal, but it's the only way to change the firmware that you have on your system to something that they haven't signed. And you're going to have to hang out on a chat room. That's just kind of what you're going to end up doing at the beginning to troubleshoot things. These are some of the links to the best places to start and the best chat room to hang out on, and a few other links. And this entire talk will be up on the BayPIGgies site probably tonight or tomorrow, or I'll put it up on my site tonight. Once you develop Python code, if you go to the wiki, you'll see all of this stuff about, build a couple of virtual machines, run it in your virtual machine. That was for when we didn't actually have the XOs. Go develop your Python code on the XO, at least as you're getting started. Eventually, as you start having serious test suites and you're starting to sort of move from trying to hack at it and figure out what you can do to building something a little more production, then you're probably going to want to build those in an emulator. Now remember, this is a Unix box. You can SSH out to it. You can, what I find is useful is you can move around flash drives, but you can SCP whatever files you need. And just so you can work on your big machine. Get a USB keyboard and mouse or you'll slowly but surely go insane. Yeah, small fingers, man. And sharing your X session on it you can do if you really need a big monitor, but it's slow. So I suggest you just sort of smile and and use the small monitor, or do most of your work on a laptop, and then once you think you have something that you should run, move it over. There's going to be a lot of cut and paste. This is true. How many people here programmed in like the early Windows stuff, like early Microsoft Windows 3.0 or before? You remember how all the examples were, this works, this is the documentation, is you start with something like this, and you copy these files, and you put them in the right place, and then you add your changes here. A lot of the XO programming is going to be like that right now. So you're going to find spots where I'll say, there's this recipe, you copy all of these files over, you tweak these two numbers, and then you go and you write your code. I'm not going to talk much about code. I was only supposed to talk for a grand total of about 5 minutes. Oh, okay. So here's your, I think the best overview of developing applications is on the wiki page called Hacking Sugar. What you'll find is that as I said, the documentation is still very amorphous, and there'll be 4 or 5 places that try to tell you the same thing, of which 2 are right and 1 is better. And you can get all the source code for everything that comes on the XO and all of the other projects that people are putting on. They're on a standard track database, so you can go check out your RCS or just view the source online. I find just looking through things in a browser will often clear up a lot of questions. But none of us have that much experience on it yet. Yes?
Is that Linus is good?
I have no idea.
Yeah.
Okay, now we get down to the nuts and bolts. I was, covering up to what does it really mean to make a small application on this? Well, we call the applications activities. And when you move them over on, you can go off and you can program in the built-in stuff. You can play around, and Pippi is an interactive interpreter. There's going to be a time that gets a lot better, but for the current release, it lets you just sort of play around with stuff. And it's got a full shell, so you can run that. But most of the time, you're going to be wanting to make one of these applications that shows up on the XO's list of nice little icons to launch. You put together a bunch of standard things. You got a manifest, and you put them all into a magic file, and you tell it that, hey, there's this magic file out there, go run it. When you do that, one of the gotchas is make sure you're running your actual current version, because under certain circumstances, especially the first time between the first and second times that you edit your version, it will actually run the old version. So I find putting a printf statement or something saying, built at such and such a time is worthwhile. You package this all up, and then you override the activity class that you inherit from, because it's a GUI, and like most GUIs, you're going in and you're insinuating yourself in some sort of an event loop. Usually you put together a basic thing in an init and put together some buttons, and then program most of your interesting stuff via callbacks. So it's going to be a model view controller style system. Most of the work that you're going to do is in PyGTK. They actually recommend that you use Squeak if you're trying to do sort of weird full screen video games, or you use Pygame. But there's Pango, which is internationalization text, is fine on it. GStreamer is how you get to the camera and the built-in camera on the system. It's also how you handle video on and off this. You'll find that you keep reaching for video as a tool in this system just because kids love it. It's great. It works. Dbus and telepathy are how you talk to each other through the mesh network. And if it seems like a lot of buzzwords, well, the best walkthrough, or the best XO buzzword definitions file is there I've seen. And it tries to sort of walk you through what's in the software stack so that you don't run through all of the buzzwords. Getting through the mesh networking is its own piece. And as promised, there's a little bit of Python code at the bottom. This is your basic Hello World application. There'll be one more slide after this. What we're doing is you'll notice that we are subclassing from a sugar class, sugar being this shell. So everything that we do is going to be running under the shell. The shell itself doesn't change. It just picks this activity up and manages it. So you're kind of at the mercy of the shell for starting you up. You import GTK, a standard thing, and this one little 2-line def hello world, logging in for hello world, is where our actual payload of all of this is going to be. And what this is going to do is it'll log something. You'll be able to view it in the system logs. You'll be able to view it in the journal. How many people have even seen an XO? Am I talking to the wrong crowd? Yeah, great. Okay, so yeah, it'll be in the journal. And this is straight off of the wiki. This is your kind of how most of this works. If you've never done GUI programming, it's always sort of backwards. You build things up, and first you say, okay, let me register myself with the GUI itself, in this case with sugar. Let me build up my whole application toolbar that's going to be on top, and then let me add in some buttons and connect that to my actual feature, and then push it all together. Yes?
Can we use Glade?
What?
Can we use Glade?
Absolutely, and you'll find that there's a tutorial walkthrough on the wiki for if you use Glade, how do you do it instead of using hand-coded. But it's really the same case of you just sort of connecting the payload through. And this makes it look also easy. Of course, this is one button taking up the whole screen. You're not worrying about layouts. You're not worrying about, well, how am I going to collaborate? A lot of times you're going to find, or at least people tell me, I haven't gotten this far in it, that you get about halfway through the program and realize your collaboration doesn't work the way you thought it was and have to reorganize everything. So this is basically programming a bit. You know, this is the OLPC and hacking on it. It's probably the most important thing that's going to come out in the last 10 years. When you look back, you'll say, oh yes, the Wii was nice. The iPod was nice. This probably changed the world. It's a very simple, solid machine. You can still get them on eBay, but we'll see if they ever have a give two, get one program or something. Are there any questions? Will somebody else sits up?
So, for those of us who know PyGTK, what percentage of it is different than PyGTK? Like, how much extra stuff will I need to learn?
The stuff that you'll want to find yourself learning will be mostly, if you haven't used dbus, and even if you have, there'll be a lot of how to get messages around the mesh network. But what you have should work. You'll find that you learn some pieces that are specific to the XO, but not as much. Also, since it's a monolithic machine, I mean, everybody out there has the same screen size and things. You'll find yourself cheating and saying, just put it at these pixel locations. You know, never mind this layout stuff. Yes?
If you're going to be giving these to places that are poor or can't afford computing equipment, roughly how much does one of these cost to manufacture?
They hope to bring it down. Right now, it's all the way up at about $185. And they're putting them into places, including spots where that's about the annual income. They have a lot of fail-safes on them that make them call home to the school server, or else they brick. They turn into an unusable lump. That is not true with the ones that are in this room of anything that people bought through the US distribution or got through the developers programs are not locked to any school server. But yeah, 185, they hope to get it down.
And they're also very, very modular. Pretty much any. Remember to repeat the question.
Okay.
Including like the backlight is held down by like color-coded screws.
Oh, yeah, taking it apart is great.
Yeah.
One of the links I really should have added is the person who did Chumby took one apart and talked about, wow, 7-year-olds can take it apart. It's an old Volkswagen. Last question, and then,
It's taking it apart.
yeah.
I got mine, it was broken, I took it apart, put it back together, and fixed it, and now an hour and a half, 2 hours.
So you fixed it in an hour and a half, 2 hours? The worst case is it's a kid who doesn't know anything and it takes 4 hours. Life is so rough.
Have like the extra dead screws in the handle in case you drop one.
Absolutely. It's just, It's the Volkswagen Beetle of computers. We'll hold other questions until other speakers have finished, I think is the best way. Sorry.
Thanks, Charles.
Thanks, Aaron.
Thank you.
Oh, sorry. Can't you just yell really, really loud?
Charles. My name's Aaron. What I'd like to tell you about now is how networking works on the children's laptop. And it uses an architecture called mesh networking. And it's an interesting kind of networking protocol. And it's fairly low level. Most of the action happens at the data link level. So it's not the kind of thing you'd be able to implement in Twisted, for example, that kind of thing. So even though I won't be talking about Python very much right here, I think you'll find it really interesting still. So what is a mesh network? Basically, in a mesh network, every node in the network acts as a relay to connect other nodes to the network as well. So every device in the network is also a router, essentially. So, and the reason this was chosen for the OLPC laptop is that it solves a lot of technical problems that are being faced in the environments that it's being sent to. So the idea of a mesh network is pretty well developed, both practically and theoretically. There's an IEEE standard for it already, 802.11s.
And this came out of MIT RoofNet, so it's been hacked on quite hard.
Oh, wow. Okay, interesting. Yeah, so I didn't know that. So there are pluses and minuses to using a mesh networking architecture. Two of the big ones, and I think were the big factors, or two of the biggest factors in it being chosen for this, are the range extension and the power efficiency. So in the, as I'll talk about, one of the good things that come out of a mesh network is that it can extend the range of a wireless network quite a bit. And that's really important in the areas where, unlike here, we don't have here pretty much everywhere you go in this area, you're going to have a wireless connection. There's also some potential power efficiencies in it, which is another really important consideration. Again, here we have electrical outlets anywhere, and it's kind of hard to imagine running out of power, but that's not always true in some places. And another thing is that the network is, a mesh network is pretty robust in the sense that as things change, it can be made to adapt automatically and be self-healing. So you can imagine a location where this is being deployed. You're going to have kids running around with their laptops a lot. Batteries are going to die. New laptops are going to come into the area. So the network topology is going to be changing a whole lot. And a mesh network can be it's robust with respect to that. There are some downsides as well. One challenge you have is keeping the bandwidth and the throughput up. Because usually, I'll talk a little bit more about that, but usually you just have a few of the nodes have a direct connection to the network, and that has to be spread out to the others. There's also greater complexity both in the hardware and software, because think of all of us have a device that's connected to the wireless internet right now. Most of us, some of us have probably like 4 or 5, and each one of those is just has a centralized connection in the sense that your device does not act as a transmitter or a router for other devices around you. Whereas, so that's there's more that has to be done at hardware and software levels. And there's also security challenges with mesh networks, as you might imagine, because basically the different nodes, which would be the laptops, have to be talking to each other almost constantly. And so to allow that to happen and everything that's needed there for the network to work well and protect privacy and everything, that's, there's some work to be done with that to make that work well. So, so once the decision was made to use the mesh network, there are a few other requirements that were taken into account. The power needs I mentioned, that was something that a lot of attention was given to. making the best use of the power available. Also, in terms of designing things in such a way that it's easy to update and can be updated software-wise. Like Charles mentioned, a number of features aren't there yet because they're planned for the future. So, and there's a lot of plans in terms of functionality and standards adherence. The 802.11s standard is in progress still. So that's deliberately planned. This one interesting thing, even though that feature is not fully in place yet, is, there's, well, actually, I'm not sure about that. But there's a feature that's either in place or will be soon in which a laptop can, even if it's hibernating, it can act as, it can participate in the mesh network. And one thing I won't really have time to go into is that the physical density of the laptops in an area makes a big difference in terms of just the effectiveness of the network in terms of power efficiency and bandwidth and throughput. So if you can have a laptop that's pulling its weight and supporting the network even though it's hibernating, that helps out a lot. Okay, I just want to mention a little bit about the networking hardware. As I understand it, when the hardware was being decided on for the how to actually make this thing, how to put it together. There was a survey was made of given the constraints of what it needs to do and the cost. It turned out there were a couple of wireless networking chips that Marvell had that turned out to be the really kind of only really good choice at the time. And Marvell did quite I think they deserve some credit for the work they did to help make this happen. They worked and donated some software and worked to make it integrated in with the hardware and everything. As a lot of you know or have heard, the OLPC project has a goal of using open source software as much as possible in the laptop. And for the most part, that's the case. It's almost all the software is open source. And the wireless networking driver is an area where it's not completely open source right now. The driver was based on a proprietary microkernel that Marvell didn't have the rights to give away to. They gave away some other code to under an open source license. So, but they didn't have the rights to that. So there's some interest in porting that driver to a free microkernel. So if someone is looking for a way to contribute to the OLPC project, if you're looking for an open source project, this is an opportunity where you can help out. And it's referenced at this URL here with this ticket is where you want to go, and you can get that URL from me later if you're interested.
And that's ARM programming.
Yes, yeah, yeah. So, I'll tell you about a little about the standard that the mesh networking in the children's laptop is based on. There are a couple of concepts in it. There's the concept of a mesh point. And a mesh point is just a node, a laptop, that participates in the mesh network. And by definition, it's also going to be a router as well that can connect other nodes to other mesh points to the network. The other concept is you have something called a mesh portal, which is basically a mesh point that happens to have a direct connection to an external internet. So for a lot of things that need to be done with a mesh network, kind of a fundamental problem is that needs to be solved is you have two mesh points, two laptops that need to find a route through the mesh network so they can communicate with each other. And the way that route is determined through a routing protocol. And there are many possible routing protocols. The standard talks about them, treats them well. There's one defined in the standard hybrid wireless mesh protocol that the laptop modifies and uses. And so basically, how it does is it uses a request and reply cycle. Yeah. So there's what happens is, first the mesh point, it knows it needs to find some route to another particular mesh point. It'll send a request packet. And this request packet, let me give you a little refresh your memory or tell you a little bit about the some networking terminology is, in the 802.11 standards, there's the idea of frames, which are basically packets. And there's a kind of frame called a management frame, which is a packet that's used specifically for determining network paths and network maintenance. You can contrast this with a data frame, which is used to deliver data and like it will have a payload. So a request packet here is a management frame, and it is sent out as broadcast because it doesn't know the path yet. And so it'll start with that request will start with the neighboring nodes and expand out. And an interesting thing happens as it is propagated. When a node receives this request packet, assuming that it itself is not the destination node, then it'll pass it along. But before it does that, it takes that information about the path from the source to itself and inserts it in its routing table and remembers that. And then eventually the request will reach its destination, and that destination will send a unicast reply packet directly back to the source. And again, that reply packet will propagate over a number of nodes, and each one of those will get the information about the route from the source to the destination, insert that in its routing table. So you can kind of imagine pretty quickly as the requests and replies go around, pretty quickly a lot of the mesh nodes will get a kind of almost a complete, you can imagine they can get a complete picture of the network topology just by storing the information and making good use of this information that's available. Yeah. It depends. It can be. There's the one I just described is if it knows a specific destination. There's also a discovery protocol too. So this graphic here just shows you. So everything I've just told you about, that kind of doesn't. That's just a group of laptops connecting in a local mesh network. It doesn't have anything to do with connecting to the external network. So, and that would be in this area here on the right, just establishing connections there and finding routes there. So if and that works fine, even if no connection to the internet is available, then you can do a lot of activities and do a lot of things with that, like the chat program and things like that. So, I'm sorry? Oh, okay. The question is what happens if people move around? Well, then the network topology changes. And if basically, if there's some sign that the picture of the network topology is not working, then it'll look for a new route. So, I'm sorry? You know, I'm not sure. The question is if they have a fixed timeout. I'm sure they do. I don't know what it is. And also, I think the algorithm that decides that is something that's going to change. I don't know precisely what it is right now. Yeah, but yeah. Basically, there's a question of how do you, if you're in a mesh network, you yourself do not have a direct connection to the external network. How do you get that connection? So what you need to do then is find a route to a mesh portal. So you're a mesh point, which means you're a laptop that's, and you're not connected to the net. And how do you find a route to a mesh portal that is connected so you can make use of that external connection? Well, there's actually it's kind of clever, I think, the way they did it. Basically, a request frame is sent out, and it's sent out in Unicast, and it's set to respond to a specific MAC address, which it's a specific number. I didn't write it down there, but it's and this MAC address is special because every mesh portal is programmed to claim it as their own and respond to it. So the mesh point will send out this Unicast request, and 0 or more mesh portals will receive that eventually and say, yes, this is my MAC address, and send a Unicast reply back to it. So so this is so what'll then basically the source laptop will get hopefully at least one responding portal, and then it'll make a choice as to which one is the best, which one it wants to use. And that's actually that's actually an important choice. And there's several ways to optimize that choice. How do you judge which portal you use is better? The algorithm that's used right now is to ask what's the path that will minimize the power requirements to send data frames. That's my understanding is that's the one that's in the laptops that are deployed right now. One optimization is planned for the future is to also take into account the remaining battery power of intermediate laptops. Yes?
So how does it determine the necessary power?
How is it
Try and
determined?
back off until it starts getting data errors? Or?
Okay, the question is how does it determine the necessary power? Well, the topology makes a big difference. So, the power required to transmit a radio signal to a specific distance with a specific intensity at that spot goes as the square of the distance, right? So that's the biggest factor. Yeah. So. Yeah, that's a good.
Can you tell how strong a signal it's getting?
But, okay, so it knows how strong a signal it's getting.
Mm-hmm.
Does it know that the other side has a fixed transmission power?
My guess would be
On
that
these school servers, yes.
But the school servers are not the ones you care about if you're too far away from the school servers to get a direct connection to the school server.
my guess would be
Well, if you're
one
going
guy
by-
screams and another guy tells him how loud he heard it.
Okay. So you transmit at full power, and then you say, oh, I got that loud and clear, and based on the amount of signal I received, you can scale back to.
Yeah. Yeah, so the question is about how you judge the distances, how you evaluate what the power is of a path is, and I don't know the exact algorithm they use, but there's heuristics for it. So yeah. So see, that's basically what I had to tell you about for the networking. Just I want to close with a little bit more pointers, just more information. First of all, I put up this PDF and all of the information I'm about to tell you on this red site. So at redsymbol.net/talks, there's a prominent link to a page for this talk. You can look at there's an interesting book on this general topic called Wireless Networking in the Developing World. And it's basically put together by a group of people that, as far as I can tell, they have no affiliation with the OLPC project, but they're interested in bringing wireless net access to areas where it's very challenging to do right now. And they wrote this book. You can download it as a free PDF. It's about 250 pages. It talks about everything from the physics of radio transmission to the details of networking protocols, including the mesh networks. And also, I just want to mention, if you want a longer and deeper version of this talk I just gave, or this segment about just on the networking itself, a company called CozyBit was basically implemented the hardware to make the networking work. And one of the co-founders of CozyBit, Javier Cardona, has a white paper and he gave a talk on it. So it's at that link right there. And if you have any questions that we're not able to get to today, then you can email me there, or you can post on the BayPIGgies mailing list, and I'll see it and I'll reply. So, and I think, thanks. So I think I can take a few questions while Ed gets ready. Yes? The question is, how do the devices pick a channel for the mesh? That's one of the things that, so there's a way it's done now, and there's the changed ways that it's planned to do in the future. And so basically, I believe right now what it does is it uses a specific, it goes to him over there. It goes to a specific, it uses a specific channel. Honestly, I don't remember. I want to say it uses a specific channel.
I only see 1, 6, and 11.
Yeah, that's right. Yeah, 1, 6, and 11. It's he's right. Yeah, it's yeah, it's
You can have separate independent meshes on different channels.
yeah. Yeah, so that's right. Yeah, it uses those 3 channels right now, and that may change going forward. So,
And you have to upgrade your firmware for more than 24 equals what you see.
oh, okay, okay, yeah, yeah.
What are the artifacts in practice? Like, do you experience your mesh breaking a lot, or does it just slow down and change speed?
Let's see. I guess none of us have had, or few of us have had a laptop for very long. I got mine, I think, about like less than 2 weeks ago. So, so far I've just I had trouble connecting with one with just forming a simple mesh of 2 nodes, and they were right by each other. But I was able to overcome that, and for the most part, I haven't had any problems beyond that one weird thing. But what's that? One of them was able to see the other invited as a friend, and the other could not. So yeah, I can't really speak to that because I didn't have like a problem besides that, because I suspect that was just like some artifact, and I wasn't in a challenging terrain. I wasn't doing it outdoors or something, so with large distances. So do you have any experience with that, Charles?
No, I do know that there are a lot of unconfirmed pieces of information that sometimes, as they hunt for each other,
Yeah.
they can be unkind to 8 or to 11B networks.
Mm.
Yeah, I've
But
seen it.
it's just rumor at this point. We don't
Yeah,
know.
I've seen it, at a conference.
Right, at
Yeah.
conference it took them down.
Yeah, it took them down, so I think it has to do with the hidden node problem where you've got 2 devices, they don't hear each other, there's a third in the middle, and they stomp on each other, and pretty soon there's excessive retransmissions, and it just knocks out everything on that channel. You should just not ever use the channel where their mesh is on.
Yeah. Yeah.
You know much about the network stack? I'm curious about things like how IPs are allocated at the school server, that kind of thing.
No, I don't. They have the server is a whole different, they have a school server, and that's a different topic. Yeah. Yeah. No.
You just put 2 next to each other, do they even get IPs?
Not just like two right our mesh without school server and that.
Yeah.
Implement zero call. I mean, it would be crazy not to implement zero call.
It does for users.
Okay.
So zero confidence line fitting in the picks an IP.
Oh, really?
Yeah, I'm familiar with Bonjour, yeah.
We can't get an image.
Oh, really? Oh, okay. I want to try. Okay. So please bear with us just a moment where we get the next one set up. No, it rejected mine as well. Yeah, we were able to get this one working.
Get this on a memory stick.
More questions?
Yeah. Yeah, while we're waiting on that for either myself or for Charles. Yeah.
I'm just wondering about the battery of this guy.
Uh-huh.
If it ran out, well, no, after 2-3 years of usage, if it ran out or a short-term abuse, can you get replacement batteries, just batteries from, if I were buying it from buy one, get one,
Yeah.
how do I get replacement batteries?
So the question is, if and when this battery runs out of juice, how easy is it to get a new one? And the answer is it's really easy. It's cheap. They're like $10. I think is that the price? Yeah, that's the price. And are you asking specifically about us in the Western world as opposed to the children in the target areas?
Yeah,
rather?
imagine
Yeah.
target there, you have a different
Right.
system.
There's a support system to make sure the kids in the schools who are receiving it will have it. And I actually, yeah, I mean, I can't imagine them not making it available to us. I mean, if we buy them. So, and also,
Yeah, I expect by the time that becomes an issue, I think like a lot of things, that by the time it becomes an issue, they'll have a solution. But before that, they just won't bother. I also expect there'll be interim solutions of people who have, in developing countries, 4 or 5 batteries that they swap through for places that do not have sufficient power at the school. Yeah, Potenko.
We can do that if all else fails. Yes.
Have you used the collaborative documents?
I think you did, Charles, didn't you?
We collaborated, I think, on a paint. We were playing around with it. Right, so far, we've had intermittent success with doing collaborations. And sometimes they work, and sometimes we're hunting around frantically for a 7-year-old to teach us what to do.
So it
Yes.
seems now that, I think this is in the firmware, that it gets to a state of charge of 50%, it just shuts down. They won't let you go below 50% state of charge. I assume for long battery life. These also appear to be the new lithium iron polymers batteries. I expect them to be expensive.
They really are. They're very, very small. So cheap.
Yeah. Well, I know I'm getting about 30, 40, 45 at the outside minutes of use. And I think that's partly because the power management.
You will have to update one, the sort of testing to the shipping firmware is stable. The power management is a lot better.
Is that 653 or is that the past 653?
I just upgraded 7.9.
Okay, so we developed you to do that, right?
Pretty good. It's been running since I got here at about 7, and with the wireless going full bore, and I'm at 52%.
Yeah.
I recorded it. I don't know what that means. 2% away from shutting down. No, I don't really know what that means. It starts at 100%, but I don't know how much the actual battery that's using.
So I assume you need the developer fee to run that build.
Yes.
It's not fine.
Yeah. Yes.
Do these ship with the dual mode display, and can you easily use that from Python GTK? Press black and white, no backlight, book reading mode, that thing?
I didn't even use that myself.
I don't think there's anything at the software level to do.
I think it's don't display colors.
Yes. Yeah, would somebody like to chat? Yeah, I think this is a good place for that.
Quite a number of people sharing various activities.
BayPIGgies chat. Are you sharing?
So how many people in here have a laptop, children's laptop? Looks like a pretty good fraction.
Oh, and it makes a great ebook reader.
Yeah. Yeah.
Yeah, one of the things I'm kind of surprised doesn't show up in the press is that it makes a great ebook reader, and it's on par with Amazon's. Look, it's a brand new ebook reader. Well, this works great. You turn the display around and use it as an ebook reader. It tends to come with, right now, the free access through every Starbucks. So I'm not quite sure why people don't talk about using it as an ebook reader more. And oh, by the way, it does something else that's cool. Any other questions? Yeah, well, basically they're all shipping with wall plugs. They're finding that there's power someplace. The big issue is that a lot of these schools are wired for one light per classroom. So there'll be sort of that at lunch everybody has to plug in their laptop type problem. That's where I think that they will come with, people will start having a couple of racks of spare batteries to get through the school day. Yeah, Colin, well, I haven't been able to actually purchase it. It's Colin Potinkin, something like it. Yeah, Potinkin or such. He started a separate company to sell them.
So
there's a string pull.
I tried using the iJuice, whatever. I found the plug for the old ThinkPad Q40 one
Right.
fit. It produces 16 volts, and while I could use it, it refused to charge.
It's
So I had to
supposed,
figure that out.
hmm,
That may be
okay.
a firmware issue, that may be, that it was a little bit above what it thought was the maximum usable voltage.
Yeah, the wiki says otherwise, but
It's supposed to be
the
fairly,
wiki's frequently wrong.
well, the wiki says 11 to 18 is supposed to be acceptable voltage range.
Let's see. Last time I looked, it was 10 to 15 to run and a wider range to charge, but I'm sure it's been changing. So anyway, power. I'm gonna tell you what I know about power, and then we'll go to sugar. The basic design idea for the laptop, besides trying to get it to $100, which we'll see about in the next few years, is that the poor of the world have very stringent design requirements, including not depending on an electric power system, being usable by illiterate people, and there are a number of others that I've written about in other places, and I don't want to take too much time. The point about power is that you can use essentially any power source that's capable of charging a 12-volt car battery, the standard storage for most renewable power systems in the developing world. So that would mean solar, wind, water, ethanol, biodiesel, animal power, or child power. We would like it to be renewable because we don't really want to get another billion people burning coal. So now for a spoonful of sugar, which is the whole idea here, that a spoonful of sugar makes the education go down very smoothly. That's me. Any particular preference? I can be Mokurai in Japanese, or Mungna in Korean, or Molai in Chinese. My Buddhist name. And also the name I use on the wiki, which is why I put it in. This is where we came from. You may remember the hand crank that unfortunately broke off in a demo. The separate handle, USB in the front, speaker arrangement different, control arrangement different, a more conventional keyboard that unfortunately water and dirt and sand and things could get into. So almost every piece of this has been changed, but the concept is the same. And the one thing about this picture that is absolutely the same is the smiles on the faces of those children. Nicholas Negroponte likes to say that this is not a laptop project, it's an education project, and I think he would have done well to call it one education per child, therefore, and not have people keep coming back, but you call it the laptop project. The idea is an educational philosophy of learning by doing, of collaborative discovery, that's called constructivism, which I don't understand where that name comes from, but I don't care. It's just a name. With free software, free textbooks, free content. And I want to emphasize this. You've already seen a little bit. In the mesh networking, in the user interface, everything is set up for children to be able to discover it. Now, there are a few bits and pieces that you can't. There's certain key combinations that are not at all obvious that, you know, maybe a few hundred or thousand children one would discover and tell the others, but it's not something. But almost everything on this computer, we already have cases of 8-year-olds, 9-year-olds, 10-year-olds getting hold of one of these, either in country or in Give One, Get One, or somebody bringing one back from Nigeria. Cases reported on the internet, cases reported in the press, where you give a child the computer and the child goes away and comes back knowing how everything works. All the programs, not every button, but pretty much how it all works, including all the language lessons that we're going to come to. And when you have multiple laptops, especially when you have one per child, it means that children can work together at all times. They can draw together, they can write together, they can browse the web together. There was a question earlier about the efficiency of mesh networking. When you're browsing the net together, and one laptop can download a web page and feed it to all the others in the group, this is way more efficient than if you're trying to download that many copies of the page through the bottleneck at the server. So there are some places where this is less efficient than a conventional network and places where it's much more efficient. We'll see how that works out. But I can't tell you enough how important it is that this is about collaborative discovery. And I mean that literally. I cannot tell you enough. I'm going to tell you just a little bit, and then we're going to go take a look at some of it. This is an example of the collaboration where you see in the upper right, 16 children or so clustered around a web browser. And as I say, the idea is that you can download a page once and feed it to everybody and not download it yay many times at the same, all together. There are 7 or 8 children painting together. There's another browser session with 5 kids, another with 2. There's a kid who's writing something and has opened up to collaboration, but nobody's joined him yet. This is the idea of what we're doing here. So collaboration, unfortunately, in many education systems is defined as cheating. And this means really rethinking the whole way we do education, but it's worth it. Some of these ideas, some of constructivism and some of the software come from Alan Kay with the Dynabook concept from the 1970s, literally more than 30 years old now, devised at a time when it cost more than $30,000 per seat to do this kind of computing. But the very first personal computers with the graphical user interface, with the Smalltalk programming language, with object-oriented programming from Xerox in the mid to late 1970s, licensed to the rest of the world in '81. The best way to predict the future is to invent it, and I'm with him 100% on that. He also says the best way to predict the future is to prevent it, and that applies particularly to questions of poverty. Jerome Bruner is one of the intellectual parents of this project. I could go on for an entire evening just on this one line. But people like Richard Feynman, Nobel laureate in physics, who have gotten on textbook committees for large school districts. People who know anything about math or physics are absolutely appalled when they have to read these elementary school textbooks at the number of flat-out mistakes and the number of what can only be described as lies. My favorite lie is the definition of a variable is a number that changes. Numbers don't change. The kids cannot wrap their mind, I mean, some of them will just, okay, yeah, we don't care about that. The question is, what can you do with them? But some kids get put off, and I know people who were unable to learn algebra in school. For decades, they thought they couldn't do algebra. And when it was explained to them, no, that's not what a variable is. A variable basically is a pronoun. It can refer to a different number at different times. We're able to go away and realize that now they actually understood all that stuff they'd been taught and could do it. So that's intellectually honest, and any stage of development. Alan Kay has examples. I can give you many more examples. I can cite all kinds of educational software and experiments and stuff about 2-year-olds being taught to read on a computer, about kindergarten calculus, about whatever. Bruner is absolutely correct, and I don't have time to go into it, sorry. And here's Seymour Papert. Of course, we have a subset of logo called Turtle Art. The book Mindstorms was really one of the first, it was the first book to explain a model of teaching computers in the schools other than like just computer literacy, basic. Okay, I don't have time for this quote either, but it's a good one. This is what we're getting to. This is going to disrupt all the education systems of all the world. This is going to disrupt all the economies of all the world. This is going to disrupt all the social orders of all the world. There has never been a technology that promised to do this for this many billion people. That is to say, 6 and something, all of them. There's nothing to compare it with. Again, I don't have time. Yes. Okay, I don't have time for any of those either. Now, let's see if we can get this. If we can get this Mac up here on the video.
I doubt it. We have a Mac video.
Oh, well, okay, you work on that, and I'll see about getting out of here and over to, okay, would you help me with a browser? Or do I know? Oh, there we go. Yeah, I'm in Windows. I've been in Windows. Firefox. All right. Host not accessible. Do we need? We need Ethernet. Okay, and then we're going to open a file, and then we should be fine. Isn't this fun? Ah, there we go. Good. That'll be up in a moment. Let's take a look. This is this set of bookmarks that you just saw. I'm going to hand over and make available. This is 20-some of the major entry points into the laptop wiki and dev.laptop.org for people who want to understand how Sugar works and how the development process works and where you can find all the information you need to get started. Can you read that okay? Good. We saw an example of the code for Hello World. Creates a toolbar, binds it, shows it. Creates a button, binds it, shows it. Okay. And since the predefined class for doing Sugar activities already knows what a toolbar is supposed to do, you get a default toolbar that does what's expected. So you don't have to know all that. Fine. Now you've written those 6 lines of code and the other bits to import whatever, and you know all that. Good. Now what? Well, this is where you come to the activity tutorial, which says these are all the steps that you're going to want to take. I'm not going to tell you all of them. But basically, you create certain directories, you create certain files, you refer to some files in other files, you make everything, and you then turn this into a .xo bundle, which is basically a zip type file. If you've done it all right, then you'll actually be able to install this, and it'll run as an activity, which means it'll have a proper toolbar on the screen, which means it'll appear in the donut on the desktop, for lack of a better word. The icon will display correctly. The menu will appear that says if you want to resume or shut down the program. All the things that are supposed to happen will happen. And then inside, it does whatever you want. Right, so this is straightforward. Now, Albert Cahalan is working on a sugarizing system which will take a non-Python program and do much the same to it. That will take care of all the external linkages, all the details of how to pass command line arguments into sugar the way Python expects to see things. Okay, thank you. And in just a moment, we're going to be able to take a look at some of these things again. So, so what? Oops. So the question then is, what would people like to see? You can see pretty much what we have here. Yeah, that's it. So I don't want to tell you what I think you should know. I want you to tell me, what do you actually want to know? Any of these things you want to see, or now I'm ready for questions. Because basically you've seen how to write the simplest possible sugar program, and you've seen that there is a straightforward procedure for turning it into an XO activity. Okay, you guys should be ready to roll. Question.
So I started reading the sugar source code about 9 months ago. It was a bit rough.
The sugar, you're talking about getting into the code of sugar itself.
Yeah.
Oh yeah, well,
Has
good,
that
good.
improved? Or has that improved, or is it still pretty rough? That, like, you know.
Everything on the XO is clearly a work in progress. And I have to say that I have never been involved with a project nearly this productive in either hardware or software. But this is not industrial development. And there are places where it's still a bit rough. It also shows if you look in the bug tracking system. But it works, mostly. Let's see.
So I have, what little API documentation I've been able to find pretty much just says, go run PyDoc.
Oh, and we're actually setting up to do, somebody is setting up to do automated PyDoc builds to go with the daily builds of the software. So you get a set of documentation that actually relates to the software you're running.
Okay.
We hope. I mean, to the extent that the doc strings are.
Sort of more bootstrappy than a long list of APIs.
Well, you see, the problem we have right now.
The simplest possible program. Fine, nobody really wants to write the simplest possible program. You know, hello
Yeah.
world is not that interesting.
Right.
The 37th time you write it in a new language.
Oh yeah.
So,
But the source code. No, I'm not recommending that anybody reads the sugar source code unless you want to help develop sugar. But the source code for the activities, like the calculator, is not too dreadful. It's all there, you know, and so you can look at the entire activity bundle, and you can look at the source code and see what kind of widgets it needs and what does what where and how all the arithmetic gets put together in a calculator.
so I'm trying to write something new.
Very good.
I want to know, you know, what are the different layouts available to me? Rather than go look
Yeah.
for all the subclasses of layouts.
Right. The problem that we have right now is that development is all being done by wizards. And wizards don't like to write documentation. And there are people like, well, I'm a tech writer, and there are a bunch of us trying to get hold of these people and trying to get hold of this stuff and nail it down long enough to actually write something that would be useful. So these things are coming, and if anybody is or knows some good writers, send them our way. Let's see, next.
Can you see the sugar components?
To see the,
Sugar components.
how do you mean?
There was a link.
Yes, you can.
Oh, okay. I'm going to come back to that. This is a live CD of OLPC software currently running on an x86 Mac. Okay? So it doesn't boot on everything, doesn't boot on my particular Linux computer, but it boots pretty widely. We can be whoever we like. So when the laptop boots up the first time, First thing a child sees is enter your name. Now, of course, if this is in first grade or kindergarten, they can't read and write yet, the teacher has to help out a little. Second thing is, do we like those colors? I don't know, do we like those colors? Those colors, well, let's, pick some colors. Everybody, it's up to you. I mean, no matter what you do, you're going to get some fairly ghastly colors. I have no idea what the cultural implication of that is. But anyway, there we are, so that's us. So now, has anybody actually not seen the Sugar UI? Oh, well, let's do it. Okay, you see the frame all around everything here. And supposedly we can get rid of this frame, but it's not going away. Oh, there we go. Okay. Here I'm showing you the wireless neighborhood of this Mac, which doesn't have mesh networking hardware, and therefore is all on its lonesome. If anybody would care to look at any of the other XOs, the actual XOs hanging about the place, you'll see a whole bunch of Google access points. You'll see mesh networking access points. You'll see individual computers all over the room. And you can, you can experiment. You can come up here and say, make friends with whoever, me, Mokurai, Guido, whoever is in the room.
What is actually implied by making friends?
That means that you would have a connection that would resume every time you're both on. And
Well, yeah, I've also noticed that.
yeah, I was about to say, that connection then shows up in other parts of the UI and you can make use of it. So the people you have made friends with will appear just those on the next screen, and then it's very easy to invite them into activities. So again, you can't see it, right? All you know is that my icon changed size. But my friends would show up here.
Right, but is there a reciprocal nature? If I made them a friend, but they haven't made me a friend?
Oh, they have to accept it in order for it to be active.
Because I've never been prompted to be accepted as a friend. I've made
Yeah?
other people friends, and I show up in my.
Everyone in the room, so I don't think anybody got it.
Yeah.
I have, well, it's supposed to be that you get prompted somewhere. I don't know. I haven't been on in the presence of enough other users at the same time to work out all these details. I'm sorry. But anyway, so this, okay, so we have the main wireless network off the screen, the local Your Friends network, the desktop here with the donut that shows which programs are active, and the journal is always active. And finally, the button that goes to whatever program is actually running. Now, if I come back here and I bring up the frame on the bottom, then you see all these activities. So now you'll notice that's the first word you've seen in this demo. Well, the C is off the screen. Okay. Sorry, we'll give you something a little more usable. Okay, so browse, write, record. That's a still camera and a video camera. It's built in. You can see the little hole on the side in the white plastic. And paint and various music programming. eToys is Squeak, which is Smalltalk. Turtle Art is a subset of Logo. We have Pippi. So now we have a problem again because all the text is off the screen. Well, we'll still manage. Okay, so I pick a program. You can't see what I'm doing, right? And we get code. And unfortunately, you can only see a little bit of it. So, magic? Oh well. At any rate, we can bring up various elementary samples of Python code. We can run them in the pane below. We can edit them and run them again. Kids get to learn starting in 3rd grade, you can show them how to change values of variables. By 4th grade, you can show them how to change a little bit of structure and logic. By 5th and 6th grade, they're writing their own. This has been tested out in a number of languages. It's been done in Python, in Lisp, in Logo, in APL, and probably even in BASIC, but I don't have a citation for that. The others, I actually know who did it. So this is not the greatest way to demonstrate all this, is it? Oh, well, here, this is actually more interesting. So now we have a full multi-track MIDI editor with a selection of, I think 128 instruments. I haven't actually counted them, but that's the usual set. Instruments from all over the world, not just these Western instruments, but koto and a didgeridoo and a gamelan and so forth. In another piece of this music software, which they separated out, there's a software synthesizer, so you can make your own instruments. And there's several other functions and features. With this multi-track editor, you can, for example, compose or record a piece, and then turn off one track and practice just that one line with all the others playing. You can slow it down to play with it. You can transpose it automatically if you want to play with an instrument that has a different natural key. You know, if you started with flute, for example, and you want to play with a B-flat clarinet, and you just drop it down to. So all kinds of goodies. And in addition, when you're collaborating, each child can have an instrument that they can play 2 octaves on the computer keyboard, and they all hear each other. Yeah.
What is the data storage format of this? Is it MIDI?
Yeah. Yeah, so very low storage requirement. We're not attempting to do MP3s, and MIDIs are, in fact, way more editable. And you can change instruments, you can change pitch, you can do all kinds of things with them. So it's quite appropriate. Now, of course, as we go on, we're going to see a lot of other stuff. Oh yeah, and different international drum kits, right. So, you know, in a few years, we're going to either see the $100 computer, the $80 computer, the $50 computer, or we're going to see systems coming out with however much more power that is per year, something on the usual order of 35% or more improvement every year. So let's see, calculator, no RPN. I was disappointed, but that'll come. Sorry? Sure. So let's see, how much, well, the same problem. But you can see algebra, trigonometry, Boolean, constants, that's pi and e to however many digits it supports. So it's an algebraic calculator. What am I looking at and why isn't it? Oh, there it is, okay. So I click on pi, and I say return, and yep, there's a value. So for calculation, up through the usual high school stuff, not for algebra and calculus, not for geometry, but for all the ordinary math and the transcendental functions and anything you would need in elementary physics, this will do the job for you. Not programmable, but yes. Okay. And an RSS feed and some games. And my favorite, the measure activity, which is that you can run an electrical signal into the sound port, anything that stays between 0 and 1 volt. And you can get a time domain record of that signal at audio data sampling rate, which I think is 44,000 something on here. So it's a digital oscilloscope. But then you can also tell it you want to see frequency domain, and it does a fast Fourier transform, and there it is. And even on this tidgy little slow computer, you really can't see it thinking. It just pops up. So, so those are the main pieces of software. Now, I've pointed out that there's very little text in most of these programs. Smalltalk is an exception. It has something on the order of 20,000 strings in the localization server just for Smalltalk, which is more than everything else put together, because there's so much program text. Because this is the entire Smalltalk language, the entire IDE, and all the activities that anybody has put together for education on this computer. So, yeah. Just a moment. Sorry?
What's 2 to the right of music?
Well, let's see. You mean this mini Tam Tam Jam?
No, no, I'm sorry, the other music. There.
Music, software synthesizer, games. This is memory, concentration, and this is a 4-in-a-row game. Okay. Wait, there was a previous question. Whether eToys is Smalltalk? Yes.
Yeah.
Right, go ahead.
You have to choose one from 1 and one from 2.
Well, how do you like that? This kid's good. Sorry.
A while ago, I actually saw that someone was in, when I was saying you have basically a Python interpreter, and you're sending this laptop to Nigeria and India.
Yeah.
Well, Python is in English. And so currently, do they have to know?
Well, you mean Python? No, it depends what you're talking about. Python's source code is going to be largely in ASCII, but Python is capable of handling Unicode. So we can write these programs to present the user interface in any language.
Well, I'm curious about the programming. I do know that, I'm bringing this up because I do know that there's actually one project where you can actually write Python source code in traditional Chinese, CHPy. And
Yeah.
I'm just wondering if a similar effort is being
Oh, yeah.
considered so that
Well,
someone
there have been proposals for full Unicode programming languages allowing all variables, all function names, and all whatever to be arbitrary Unicode text.
But what about reserved words? They're probably going to be, yeah, because.
Well,
CHPy
the question is,
actually changed.
the question is, do you want to keep the reserved words fixed so that you don't have a problem going from one version to another, and you are not going to run into any kind of collisions where somebody who's doing Chinese Python decided to use something in English that they're not going to be allowed to if the program gets converted? Do you want all that purity, or do you want the kids to be able to hack at pleasure and deal with the problems as they arise? So yeah, there should be multiple versions. There should be a full Unicode Python.
Well,
That's my point of view.
yeah, well, my point of view is, well, English is such quote-unquote widespread that they'll eventually have to learn it anyway if they learn it by
There's
programming
plenty of
Python.
there's plenty of precedent for this. Russian COBOL in the 60s allowed Russian variable names but used English keywords.
That is actually what Python 3000 will do.
Which?
It will keep the English keywords and the English standard library and built-in
Uh-huh.
function names, but it will allow you to define your variable names and function names and class names using any Unicode
Excellent. I wonder when we can get it on the laptop.
In 3,000.
Thank you. I walked into that one. Next year. Very good. Yeah, what else have we got? Oh, turtles. Woohoo! It's turtles all the way up. Forward, right, forward? Huh?
Oh, there we go.
Yeah, there, yeah. Sure you go.
Very nice.
Yeah, so in fact it goes forward 200.
It goes every time I click. It goes 100 and then right and then on.
Yeah, so, okay. But the side of the square is 200 because it's in two segments of 100 each. And your circle and blah, blah, and okay. Spirograph, do a spirograph. Come on.
Do what now?
Do Nautilus.
All right. I need some numbers. Where do I get me some numbers?
Yeah.
What's the web browser like? List of capabilities.
Well, you don't get tabs and that sort of thing. It's based on Zool Runner, which means it's like Mozilla. And since you don't have tabs, I suggest opening multiple instances. But unfortunately, the user interface doesn't tell you what page it's on when you're in the donut. So it's very difficult to keep track of your different pages.
But just one page can have JavaScript running in the page?
Oh, yeah. Oh, yeah. We run, my stick is over there. We run TiddlyWiki, which is entirely JavaScript. Yeah.
Stuff like Gmail works. There is an Opera RPM that you can download and actually wrap it in an activity if you want to. I haven't tried it yet, but I know it's out there. And it does tabs and stuff. Flash isn't terribly well supported right now.
There was a discussion on Flash today, and the claim is that the Nash people have broken the last of the secrets for the codecs. This only leaves patent issues remaining. So we'll see. Yeah.
I have a question about what's needed going forward. I know there was a lot of hacking about a year ago.
I'm glad you asked that.
Well, there were issues with the firmware and the power management. I know
Yes.
everybody's over the hump now.
There are issues. Take a look at the track system. Go to dev.laptop.org. I'm interested in bug number 46. Oh, very nice. I'm interested in bug number 46, the one about the Marvell firmware, because I talked to Stallman at Linux Cabal, and he says that's the only impediment to him fully supporting the project. Which that's Stallman. And but he would go around the world and tell countries to buy this if only we got rid of that Marvell microkernel. Sorry?
I doubt the Congo is waiting for Stallman to go ahead.
He has had an interesting impact in some countries by going and telling the whole country that the government should be using only free software for reasons of freedom and security. And I don't know how many countries, how far he's changed minds and policies, but it's out there along with, for example, the famous senator's letter from Peru to Microsoft about, people know this story? No? Oh, yeah, well, it's one of those famous stories. Unfortunately, I can't think of exactly how you would Google it, but I think if you do Senator Peru Microsoft free software, it'll come up reasonably high. It's all about how he thought the country should go to free software. Again, for reasons of cost, freedom, and security, because Windows is horribly insecure to begin with, and your data is then locked up in proprietary formats, and you may never see it again.
More importantly, your data is locked up in proprietary formats owned by a company that may be hostile to your country's interests.
And the idea of wanting to extract that much money from your population is viewed as hostility by a number of governments. Yeah.
Beyond the core system
You want to get on the library mailing list.
Because it's such this distributed network, mesh network, there are probably some interesting things you can do with this.
Oh, we already know there's hugely interesting things you could do. We don't have enough brain power and time to do everything we even know now we need to do. We've got to get the kids on this. We've got to get, in a year, there will be children who can tell us really what we should be doing for them. In 2 or 3 years, there will be children helping with the open source development. We already have children writing their own games, educational games. Yeah?
How about textbooks?
The idea here is to have all free textbooks, all written by the community.
Is there an adequate reader and
Yes.
do the schools have an archive, or how does that work? Yes.
There's a library. Can you go to the browser and get the library up? There's a library of children's picture books, science books, literature, various stuff, currently available, a small selection. Built in. Plus, I recommend that you go to librarianchick.org and check out all the free textbooks there.
I know where they're online, but if this is delivered to some third world country.
Yeah, well, we started with a small selection, and then the question is, okay, what textbooks for what subjects in what languages? And so now governments are talking to their textbook publishers. Okay, can we have an electronic version of that book now for these kids? And as far as possible, we want to see free electronic textbooks. And then the step after that is not just the textbook that exists, not just the words and pictures, but a textbook that calls on all the software that's built into the XO to do your simulations, your demonstrations, your animations, your interactive explorations, everything we can think of in that vein, yes.
So do schools put in firewalls to block pornography or subversive political
Just open a fresh browser.
web browsing?
It's supposed to open at the library, sorry.
Libya, a big firewall to prevent connecting the children to the Scientologists in the U.S. or something?
The first deployment, they did the guy from OLPC laptop.
Ivan Kirstich
Yeah, yeah,
in Uruguay, yeah.
yeah. I don't remember his blog name right now, but you can find it off the wiki, wiki.laptop.org. He talks about the filtering software that shipped with it. It was an open source filtering product that I don't remember the name of. It shipped on an IBM server.
Mm-hmm.
Basically, it's left up to the local governments to decide how and if to do that. And they mentioned a couple of common,
Yeah, and whether they're happy with the open source package or they want to get their own or whatever they want to do. Yeah, there was a lot of fuss from Nigeria.
well, a lot of fuss from Nigeria about a number of things. I haven't heard about the filtering fuss, but
Well, it's just that it was reported in the press that some school children had found pornography on the web.
I'm shocked.
So, there was a call for filtering and so.
It's disruptive in a variety of ways. They start getting around the firewalls and start getting VoIP apps. They pay for encryption.
Oh, starting. Who's read Ender's Game? It's disruptive. Yes.
So one good criticism I think I've heard over the OLPC is that they want kids to learn things that'll help them later on in the working life, and I think that's Windows.
Just a sec, I couldn't hear you clearly.
Oh, they want kids to learn computer skills that'll be relevant to getting a job someday, and I think that's Windows.
Oh, you mean the governments think it's Windows?
Right. Well, it is right now.
That depends on the environment in your country, because if you put Linux in the schools, then the environment in your country will be Linux.
Yeah, but I'm just wondering if there's any effort to try to make machines like this available to small businesses, cash registers, and controllers and communications, internet cafes in these developing countries. They're clearly appropriate for
Yes.
small.
Not from one laptop per child, but I could point you to several dozen companies that make other small laptops or brick computers or embedded systems of various kinds using Linux or Windows CE or a half dozen other major small system embedded operating systems. Yes, the existence of these markets is well known to many, and there are a lot of people who, in a lot of big companies, who are paid to think about their emerging markets strategy.
Including Intel?
Oh yeah. Intel, Cisco, absolutely, Microsoft, but also cash register companies and companies, people doing WiMAX, people doing ISP kits, everybody, everything you can think of that you can imagine somebody would need in a developing country. There is somebody working on a product and a distribution method to get that out, and in some cases with insufficient imagination. So there's still a lot of openings. But yes, this is happening. This is going to be the economic story of the next generation, is these markets growing up at a fantastic rate.
What do you think about the announcement like yesterday or today about the OLPC collaborating with Microsoft to dual boot the EXO Windows Linux? That was just announced today.
Well, Microsoft announced something like a year ago that they were going to put Windows on the machine. They announced over a month ago that they were within 3 months of getting XP to boot if you provided an extra 2G. And Nicholas Negroponte's official expressed attitude to Microsoft is, good luck to him. Sure, the more the merrier, he says, except when it's Intel, because they had an agreement that one laptop per child would get primary education, Intel would go for secondary, and in fact, Intel's people kept trying to sell into primary, even in cases where one laptop per child already had the contract. So that's where all this fuss that you've heard of about them breaking up came from. Of course, I don't know what they thought of. Well, I guess I do know. I have a vague idea what they were thinking of. They were thinking of John Negroponte bringing them together. Yeah, over here.
One could argue that the firewalls in the schools are simply an advanced course for some of the students.
Oh yeah. Oh yeah. It's definitely going to happen. No, there's no question that much of the time you want the children in a school to be able to connect with the children in that school. When they're in class, when they're doing homework, that's the first line. Then you need to provide some way of getting outside your own school so that schools can collaborate all over the world, preferably. And everybody who is in a position of authority over children apparently agrees that you have to control access in both directions. You have to prevent people getting at the kids, and you have to prevent the kids getting at certain kinds of stuff. Which I don't agree with that much, but really? Okay. But it's certainly a fact of existence in this world, yeah.
So I've heard about the fabled view source button, and I was talking about with the guy yesterday, and we were hoping that eventually, not only would you be able to view source, but fork a user line to copy of any program and start modifying the program. Is anybody thinking about that?
There's a lot of thought about this sort of thing. The problem is that that's a developer issue and not a student issue. Because
I want the students to fork the program. If I'm a kid, I want
because we can't put the entire source code on the laptop. Therefore, we can't in 1G.
Python programs?
Well, and also Smalltalk, and also, I don't know what else is on here, but pretty soon we're going to have SimCity. And pretty soon we're going to have a sugarizing factory so that any piece of software that you can get the rights to, you can wrap in Python and run. You've heard the term script kiddie, right? Okay, these kids are going to wrap everything they want in Python and run it, with or without the help of these advanced tools. Now, what's going to happen is the kids are going to discover the command line, they're going to discover Git, and they're going to get their copies of the source to whatever in the usual way. Now, as far as forking, the question is, do you want an official fork in a repository, or do you just want something you can work on?
I want to be able to take any program running on my laptop, hit the view source button, and say, oh, that's interesting, but I want it to work my way.
Right. Well, so you've seen Hello World. So now if you can imagine a program that has one button that says view source, but it also has a little menu that says all the different programs that are currently installed, which you can ask Yum about. Right? So this is not a difficult Python programming task. And away you go. Do it. The kids will thank you. Yeah.
So what's the status like for accessibility on these?
We have text-to-speech. There's some applications being written right now to make use of it. Most of the Linux accessibility software can be installed with Yum in the normal manner. And I don't know the details, I'm sorry. It is possible to turn this into a blind person's programming system. It is possible to set up sticky keys and let people type with a mouth stick if they can't use their hands normally or don't have hands. And many other of the usual possibilities are all there.
I saw earlier in one of your bookmarks, Sugar on Ubuntu.
Yes. There's a whole page of Sugar on different distributions.
Can you give me a large, like 2-minute overview of how roughly is it installing it there, or is it making a chroot?
There's two usual methods of doing this. One is to get an emulator like QEMU or VMware, which is what, $189? VMware? Oh, you can set it up in a free player. Oh, goody. Well, see, I didn't know about that. Okay, yeah, VMware, they tell me, is considerably easier and more reliable than fighting QEMU. But it has been done. And the other method is to build Sugar on your system, which is easy to do in Red Hat-derived systems and difficult to do in Debian-derived systems. But you can go look on the wiki, and you'll see that Debian and Ubuntu and several others have been done. Good luck, because your system is, let's see. Oh, and the very first encounter I had with all of this was with Guido on the Devel list saying that he was building Sugar on Debian at that time, and then a bunch of other people came in and built on Ubuntu and so forth.
Actually, I never got it to work.
Ah, yeah, well, neither did I at the time, but I think we both learned a lot.
Well, I actually learned that the developer environment sucks. Needs a lot of work.
Yeah, yeah. Now, I'll go back to what I said before. This stuff is being built by wizards who feel that they're in too much of a hurry to build tools to build the programs, and they're concentrating on building programs. We need the tool builders. I generally consider that being in too much of a hurry to build tools is a mistake, but that would be an argument for a different night. Okay? What, I can't have answered all your questions. Okay, so these are all the current questions. Here's, yes, very nice. One of the Smalltalk tutorials, the eToys tutorials, where to start, you just, you click the door, and then you move the key to the keyhole, And now you can click the door. Yeah, it comes and goes. Isn't that nice? And then, oh yeah, then you have to learn to use the mouse type buttons. What? What? I think it's Option or Command click or something like that. Try Command, Apple click. There you go. You got it. Hey, it went away. There. No press again. Oh, yeah. Okay. Anyway, yeah, it can be done even on a Mac. But anyway, the point is it's going to teach you all the handles around Smalltalk type objects. Not all of them, but it's going to teach you the resize and the rotate and a little bit. And we all know that there's also a handle that opens a code viewer. And then you can change the code, and, you know, or clone it and make a new object and whatever you like. So this is a very powerful environment. Yeah, here you have to make a copy of your key, and so forth and so forth. So this is a very powerful environment. Pippy for Python is a very mild set of lessons. It's just very simple programs that you can run and change the text of. Whereas here you're actually doing objects from the beginning. So if anybody feels like building us a nice Python environment for this sort of thing, in which we can do something like that, the kids will thank you. There was a question earlier about what else is needed, and I can give you a short answer. Everything. But if you have any more specific questions about what's needed, I'd be happy to help you with that too. You know, we obviously need the usual school subjects. So we need math and science and languages and history and geography. I can't tell you how happy I am at the thought of something like Google Earth becoming available to all the school children of the world, where you can zoom down, you know, and see the pyramids and the Sphinx from above, or you can go over to whatever, wherever, you name it, your favorite part of the world that nobody else knows about. And then you tell them. And then we need ideas that haven't been had yet, because we don't know all the ways that we could make standard subjects interactive or introduce new subjects. Some of us are thinking about getting kids together to plug weather stations into the measure activity, air and water quality, type in health statistics, I don't know. Aggregate this stuff all over countries wherever the laptops are deployed, and send it to professional geographers for cleaning and analysis and publication back to the country so that everyone can use them. And we already know the value. Was it in the 17th century, a statistician mapped the incidence of cholera in London and found that it clustered around one well, and when they shut down that well, the epidemic stopped. The same kind of thing can be done with diseases like malaria and river blindness and AIDS and what have you, that we can find the focal centers of a lot of these things and prevent them, which is way cheaper than curing them. We can find health problems in rivers and in air pollution and go back and find the sources. And depending on the political climate, we may or may not be able to do anything about that in a particular country, but if you have the information, you're better off than if you don't. So when I say everything, the question I always like to put to people is, what do you know that the children should know but don't, that their teachers also don't know? Please come and tell us about it on the wiki and think about how you can put it into software or textbooks or whatever the case might be. Or just hand your idea over to someone else who can run with it. Okay?